Every device on the internet has an address. But here's the thing nobody tells you. We almost ran out. By the early 1990s, the internet was heading toward a complete address collapse. And the fix they came up with? It changed how every network on the planet works to this day. I'll show you exactly how it works and why it still matters right now. In this video, you're going to learn what CIDR actually is. No textbook definitions. No memorizing formulas you don't understand. You'll learn why the old system was broken. You'll see how CIDR fixed it. And by the end, you'll be able to read one of those weird slash addresses like 192.168.1.0/2 and actually know what it means. Hold on to this question. Why does a simple forward slash save millions of IP addresses? We'll get there, but first let's talk about the disaster that made CIDR necessary. Back in the early days of the internet, engineers needed a way to organize IP addresses. An IP address is just a number, a unique label for every device on a network. Think of it like a mailing address, but for computers. The system they built was called classful addressing. It divided all IP addresses into three buckets: Class A, Class B, and Class C. Class A was huge. One Class A block gave you over 16 million addresses. Class B gave you 65,000. Class C gave you 254. Sounds flexible, right? Well, here's the problem. Say your company needed 300 addresses. Class C only gives you 254. That's not enough. So you had to upgrade to Class B. But Class B gives you 65,000 addresses. You only needed 300, but you got 65,000. That's like renting a stadium because your apartment was too small. The extra 64,700 addresses. Wasted. Gone. Unusable by anyone else. This was happening thousands of times across the internet. And by 1993, engineers realized that at this rate, we'd burn through every available IP address within a few years. So what did they do? They didn't just patch the problem. They rethought the entire idea of how addresses get grouped. And the answer was surprisingly elegant. CIDR stands for Classless Inter-Domain Routing. The word classless is the key. It means to throw away the rigid Class A, B, C buckets. Instead, you get to define exactly how many addresses you need. Not 254, not 65,000, exactly what you need. Here's how it works. An IP address is made of 32 bits, 32 ones and zeros. CIDR lets you draw a line inside that address. Everything to the left of the line is the network part. It identifies the network. Everything to the right is the host part. It identifies the specific device. That line? That's what the slash notation tells you. When you see 192.168.1.0/24, the /24 means the first 24 bits are the network. The remaining 8 bits are for devices. 8 bits gives you 256 possible combinations. Minus a couple reserved addresses, you get 254 usable device addresses. Now, here's where it gets powerful. What if you only need 30 addresses? Use /27. That leaves 5 bits for devices. 5 bits equals 32 combinations. Exactly what you need. No waste. And here's the part that surprises most people. This same slash notation is used to control how internet traffic is routed across the entire global internet, not just your home network. We'll get to that in a second. Let's make this concrete. You see this. 10.0.0.0/8. The /8 means 8 bits are locked to the network. That leaves 24 bits for devices. 24 bits equals over 16 million possible addresses. That's a massive network. Now you see 172.16. 0.0/12. 12 bits for the network, 20 bits for devices, about 1 million addresses, mid-size, and then 192.16, 8.0.0/16. 16 bits each way, about 65,000 addresses. That's a common setup for medium business networks. Here's a quick rule of thumb. The higher the slash number, the smaller the network. /8 is huge. /24 is a medium home or small office. /30 is tiny, just 2 usable addresses. Perfect for a point-to-point link between 2 routers. Wait, why would anyone want a network with only 2 addresses? That sounds useless. But it's actually one of the most common configurations in professional networking. The reason why is pretty clever, and I'll explain it on the next slide. Your home router right now is almost certainly using CIDR. That address, 192.168.1.0/24. I mentioned earlier, that's the default network on most home routers worldwide. Your laptop, your phone, your smart TV, all getting addresses from that /24 block. But CIDR goes way beyond your living room. Internet service providers, ISPs, get assigned large CIDR blocks. Say an ISP gets 203.0.113.0/21. That gives them about 2,000 addresses to hand out to customers. They can then slice that block into smaller /24 chunks for different neighborhoods or regions. This is called subnetting, and CIDR makes it possible. Now remember the question I left open? Why use a /30 with only 2 addresses? Here's the answer. When 2 routers connect directly, they only need 2 IP addresses, one for each end of the link. A /30 gives you exactly that, and wastes 0 addresses. Before CIDR, you'd have had to use a /24 and waste 252 addresses on a link that only needed 2. CIDR made the internet efficient, and the timing was perfect, and because just a few years later, the internet exploded in size. Here's the thing about CIDR that most people miss. It didn't just solve a storage problem, it solved a routing problem. Before CIDR, every router on the internet had to know about every individual network. That table of routes was growing out of control. Routers couldn't keep up. CIDR introduced something called route aggregation, or supernetting. Instead of advertising 256 separate /24 networks, a provider could advertise a single /16 and cover all of them at once. One entry, same coverage. That's why the internet scales. That's why your router can find a server in Tokyo in milliseconds. Billions of devices, millions of networks, all organized and routed using the same / notation you now understand. The / saves millions of addresses because it removes the rigid walls between classes and lets every network be exactly the size it needs to be. No more, no less. That's CIDR. And once you see it everywhere. Quick question for you. What's the network you use most often? Is it a /24 at home? A /16 at work? Now, if CIDR made sense to you, you're ready for the next step. I hope you enjoyed the video. Leave a comment down below and let me know what you would like to learn about next. Thank you.